Hello students, welcome back to Sleepy Series. This is last part of RCC Revision Series. Tonight, we slowly revise. Prestressed concrete, losses of prestress, important IS codes, and rapid-fire RCC revision. Relax your mind, no pressure, no panic, just calm revision. Listen slowly, and let the concept settle naturally into memory. Prestressed concrete is a special type of concrete in which internal compressive stresses are introduced before external loading. The main objective of prestressing is to reduce tensile stresses and prevent cracking. Concrete is strong in compression but weak in tension. Prestressing introduces compression so that tensile stresses produced during loading are reduced or eliminated. Prestressed concrete allows longer spans, smaller deflection, lighter sections, and improved durability. Important code for prestressed concrete is IS 1343. Prestressing steel usually consists of high tensile wires, strands, or cables. High-strength concrete is necessary because prestressed members carry high compressive stresses. Minimum grade of concrete for prestressed concrete is generally M30. Now methods of prestressing, pre-tensioning, and post-tensioning. In pre-tensioning, steel tendons are stretched before casting concrete. After concrete gains sufficient strength, tendons are released. Bond transfers prestressing force from steel to concrete. Pre-tensioning is commonly used in sleepers, electric poles, and precast members. Now post-tensioning. In post-tensioning, concrete is cast first. After concrete hardens, steel tendons are tensioned using hydraulic jacks. Post-tensioning is commonly used in bridges, large span roofs, and heavy structures. Ducts are provided inside concrete for tendon placement. After stressing, grouting is done to protect tendons from corrosion. Now methods of prestressing based on anchorage system. Important methods are Hoyer system, Freycinet system, and Magnell-Blayton system. Hoyer system is mainly used for pre-tensioning. In Hoyer system, bond between steel and concrete transfers pre-stressing force. Steel wires are stretched between rigid abutments before casting concrete. After concrete hardens, steel is released and compression develops in concrete. This method is commonly used for sleepers, electric poles, and precast members. Now, Freycinet system. Freycinet system is mainly used for post-tensioning. High-strength steel cables are stressed using hydraulic jacks. Special wedge anchorages are used to hold tendons. This method is widely used in bridges, large span beams, and heavy structures. Now Magnell-Blayton system. Magnell-Blayton system uses flat steel wires with special anchor plates. Steel wires are anchored using wedges and plates. This method provides efficient force transfer and reliable anchorage. It is commonly used in bridge girders and prestressed beams. Now advantages of prestressed concrete. Longer span capability, reduced cracking, reduced self-weight, higher durability, better water tightness, lower maintenance cost, improved serviceability. Prestressed concrete sections are thinner and lighter than conventional RCC sections. Now losses of prestress. Prestressing force gradually reduces with time. These reductions are called losses of prestress. Main losses are elastic shortening, shrinkage of concrete, creep of concrete, relaxation of steel, friction loss, and anchorage slip. Elastic shortening occurs immediately when concrete shortens elastically during prestressing. Shrinkage loss occurs because concrete loses moisture and shortens with time. Creep loss occurs due to long-term deformation under sustained stress. Relaxation of steel means reduction of stress in steel under constant strain. Friction loss develops mainly in post-tensioning due to friction between tendon and duct. Anchorage slip occurs during transfer of prestressing force. Creep and shrinkage are time-dependent phenomena. Higher water-cement ratio generally increases creep and shrinkage. Now, cable profile. Cable profile is arrangement of tendon inside member. Parabolic cable profile is commonly used in beams. Cable eccentricity helps in resisting bending moment. Now, end block. End block is anchorage zone near beam ends. Very high local stresses develop near anchorage. Special reinforcement is provided in end block region. Now, kern of section. Kern zone is the region inside section within which compressive force should act to avoid tensile stress. If resultant force lies outside kern, tension develops inside concrete. Now, comparison between RCC and prestressed concrete. RCC members generally show more cracking and larger deflection. Prestressed concrete shows smaller deflection, better crack control, and better durability. RCC construction is simpler and cheaper for small spans. Prestressed concrete becomes economical for long span structures. Now, important facts. Prestressing introduces compression before loading. Pre-tensioning is generally used for precast members. Post-tensioning is commonly used in bridges. Prestressed concrete reduces cracking and improves durability. Friction loss occurs mainly in post-tensioning. Relaxation means loss of stress in steel under constant strain. Now, important IS codes revision. IS 456, main RCC design code. IS 1343, prestressed concrete code. IS 1893, earthquake resistant design. IS 13920, ductile detailing. IS 875, loads on buildings. Part 1, dead load. Part 2, live load. Part 3, wind load. Now, rapid fire complete RCC revision. Concrete is strong in compression, weak in tension. Steel is strong in tension. Minimum RCC grade, M20. Minimum prestressed concrete grade, M30. Characteristic strength, FCK. Target mean strength, FM equals FCK plus 1.65 sigma. Young modulus of concrete equals 5,000 root FCK. Maximum compressive strain in concrete, 0.0035. Design stress in steel, 0.87 Fy. Under reinforced section is preferred. Over reinforced section is brittle and unsafe. Shear reinforcement resists diagonal tension. Development length, LD equals phi sigma S divided by 4 tau BD. One-way slab, longer span divided by shorter span, greater than 2. Short columns fail by crushing. Long columns fail by buckling. Pile foundation is deep foundation. Punching shear develops near column. Prestressing introduces compression before loading. Creep causes long-term deformation. Shrinkage causes shortening of concrete. Relaxation reduces stress in steel. Good detailing, good curing, and proper cover increase durability of RCC structures. And now, the complete RCC revision has slowly settled into memory. From concrete basics to beams, shear, slabs, columns, footings, and prestressed concrete. No pressure, no panic, just calm revision, slowly becoming long-term memory. Good night, students. Sleep peacefully and keep revising calmly.